here we go. Let's talk to it. 4.5, standard variation. Okay, standard variation. It's a little statistics for you. Okay, that's our first kind of intro into a little statistics world. Okay, what's our first question say? It says a manager of a fast food restaurant, which employee collects a sample of 6 orders for several employees who work in a drive-through window. Which employee has the fastest, or excuse me, best order times? Explain your answer. So I want you to take a minute and think about this. Your answers are going to vary. There's no 100% right answer or 100% wrong answer here. But just look at the data, okay, and see if you can, come up with an answer for that question. Go ahead. All right. So after looking this over, to me, first thing I notice is that Anna has the fastest to actual time. Okay. She also, at the same time, has the slowest time. So Anna's the most, quickest, but also the slowest at the same time. So that's kind of inconsistent. So I don't know if she has the best order time in my mind. If I continue to look at this, Elisa has the most consistent time. Okay, the most consistent time. So personally, I would have said Lisa or Malcolm is extremely consistent, from like 140 to 150 pretty much. That's pretty consistent. Zach is quick, but also very slow at the same time. Jason is all over the place. Okay, so I would say Elisa or Malcolm. Why? Because they are both extremely. Malcolm probably being the faster of the two. All right, so what are we doing today? Today we're talking about standard variation, and what we want to figure out is how how good our data set is, how close data set is, how close to the mean it is, how close to the average it is. That's what kind of standard variation is. Standard variation, it says use the formula. It's not really. It is a formula technically, but it's more, in my mind, it's more of a process. There are about 5 steps to it. All right, and by no means would I expect you necessarily to memorize these 5 steps, but I definitely would like you to know. You're going to need to know how to do them, how to execute these 5 steps. All right. So how do we find that standard deviation? What does it say? Standard deviation of a data set measures the spread of data about the mean. So let's look at how it's developed and seen in action. So here's a scenario. The biology department has a course with only 4 sections per semester, and here are the class sizes. All right. So the first thing we need to do is calculate our mean. Remember, mean is another way to say average. The average of these 4 classes is 23 students. So the mean is 23. So the next thing we need to calculate, all right, how much does each data value deviate from the mean? All right, and what I'm talking about is I take my data point of 20 and I subtract the mean from it to figure out how far away, how close it is to the average. All right, what are we trying to calculate? We're trying to calculate how tightly packed our data set is, or if there's any outliers. Okay, so if I do 20 minus 23, I get -3. 21 minus 23, I get -2. 24 minus 23, I get +1, and 27 minus 23, I get 4. The next thing we want to do is we only want to deal with positive numbers. All right, we only want to talk about positive numbers because we can't really define standard deviation. We can't necessarily calculate our standard deviation with a negative number because we're going to have to take a square root at some point. So to address this issue, our book suggests that we square the deviations from the mean. And what I'm talking about is I square each of these 4 numbers so that it becomes positive. So -3 squared, -2 squared, 1 and 4. -3 is 9, 2 squared is 4, 1 is 1, and 4 squared is 16. Our next step asks to take the average of these numbers. So add these four numbers up and divide by 4. 9 plus 1 plus 4 plus 16, and divide by 4. So we square the numbers to overcome the issue of negative numbers, the negative numbers we're presenting, but we got to change, but the operation changes units as a result. To compensate, we have to take the square root. So the result of the standard deviation is, okay, we're about 2.74 students from our average, all right? So I just talked a lot there. We're going to practice that in a minute. So standard deviation, I want you to take a minute and read. Well, the biggest thing from this paragraph that I want you to take away is the smaller standard deviation is, the less spread out from the mean. Okay, the larger standard deviation is, the more spread out from the mean. The smaller standard deviation, the more consistent the data values are. That's important. Obviously, larger, less consistent they are. All right, so the following list summarizes the operation used to find a standard deviation of a data set in order that they are performed. Next to each step, write a mathematical notation using the summation symbol as a shortcut. For example, instead of writing add the x values, write sigma x. So that big Greek letter sigma means sum in math. So the first thing I want to do, what we're trying to do here is think of a formula for our standard deviation. All right, so I'm going to subtract the mean from each data value. So I'm going to do, if I have a data value x, I'm going to subtract the mean. And we talked about doing that when I got the -3. It's at the bottom of page 484. Now, whatever I get, I'm also going to square that result. So I'm going to do x minus the mean and then square. Well, it says to add those numbers. So I'm going to add those numbers. Well, how do I add? When I say add, I want to use this summation symbol. So I'm going to say sigma of those numbers that I just found the previous step. Now, you're probably looking at this like, what the heck is going on? Where is he coming up with this? When we get to the practice of these, it'll make a little bit more sense. Now it says divide the sum by number of values. Why am I doing that? To find the average. So I'm going to do this divided by the number of values, and step 5 is to take the square root of the result. So I'll square root that whole thing. Now there's a step-by-step process that we're going to follow. I mean, this is a step-by-step process. All right, but I'll organize it a little bit better for you. We'll make it make a little bit more sense. Okay. Let's look at an example. Pastry chefs use accurate scales. Just read that. All right, so assume the chef uses a measuring cup to measure 1.5 cups of flour 3 times. The chef weighs the flour to assess the consistency of her measurements and finds these weights: 175, 192, 179. Find the standard deviation. So the first thing I need to do is find the mean. I'll find the average. So I'm going to add these 3 up and divide by 3. That's first. What I like to do is write each number out, okay, underneath that. I'm going to say 175, and you'll see why in a second. 192, 179. So I'm going to put the number, how far away they are from the mean, underneath it. So 175 minus 182 and get -7. 192 minus 182 and get +10. And then 179 minus 82 and get -3. Now I'm going to, so this is x minus mean. Now I'm going to do square it. So I got 49, 7 times 7, 100, 10 times 10, and 3, which should be not 3, 9. Next step after I square it all is to find the average. So I'll just write average. Average of these three numbers, I'll do 49 plus 100 plus 9 divided by 3. So I do 158 over 3, and I get 52.6. I'm going to square root that number. Standard deviation equals 7.26. And then since our weight was in grams, this will be in grams as well. Oh. So it seemed like a lot of process, and we're also going to start using tables to help us as well with this, all right, on these next couple. But whoops, wrong button. If a chef measures flour using a scale and gets exactly 185 each time, what's the standard deviation and why? Well, if he gets 185 every single time, it doesn't change. That means our average is 185. So the standard deviation is 0 because, why? Because there's no variation in our data. All right, because it's always 185, it's consistent. Okay, so how it works, this gives you a step-by-step process, okay? What I was talking about, this table is what I'm gonna like to use, all right? This is how I kind of want to calculate it. Why do I want to do it this way? Because in this last row, you'll see that you find the average, and all you need to do to get your standard deviation is take the square root of this column, of this 8 here, and that gives us our standard deviation. So let's try that. Okay, and I believe, yeah, we'll stop at part B. Potentially we'll just stop at part A, actually. All right, so what I'm going to do, the class sizes are this. Okay, find the standard deviation, so I need to calculate the mean. So the mean is the average. Remember, I'm going to add these 4 numbers. And divide by 4. Mean ends up being 68. X minus the mean. 60 minus 68, I get negative 8. 63 minus 68, negative 5, 0, and 13. So our average, which we just found ourselves, was 68. That's our mean. We want to take the average of these numbers as well. 0. And then I'm going to square every single one of these. Square every single one of these. After squaring all of these numbers, I want to find the average and put it down here. So add these 4 numbers up and divide by 4. That step, square root of 64.5. 3 students. All right, we're going to stop there and then we'll pick it up